I'm your host, Dr. D. Welcome to Math in the House. Today, we're doing Math Analysis, Chapter 7, Section 2, the Law of Cosine, and the area of triangles. I'm your host, Dr. D. Okay, so our next section, we have another law. Another law? Yes, this is the law of cosines.
Just the facts, ma'am.
Okay, law of cosines is c squared equals a squared plus b squared minus 2ab cosine c. Now, let's take a look at what that actually means. If we have a right triangle, then we know the Pythagorean theorem says that c squared equals a squared plus b squared. Now, let's say we take our angle C and we close it up a little bit. We make it smaller. So it's not 90 degrees anymore. It's, let's say, 70 degrees. So angle C is acute. Well, now c squared doesn't equal a squared plus b squared. It equals less than that. Because when I close angle C, I make side C smaller. So that's why we have this a squared plus b squared minus something. So minus 2 times a times b times cosine of angle C. Now, let's say we make angle C bigger. Well, now side C is bigger. But now, notice minus 2ab cosine C. Well, cosine of an angle that's bigger than 90 degrees, remember that's an angle in the second quadrant. And in the second quadrant, cosine's negative. So this becomes minus a negative, which makes this bigger. So C gets bigger as it should. All right, so let's just look at all three of these then. Any side squared equals the sum of the squares of the other two sides. That's our first thing. Minus 2 times AB or AC or BC. So whatever two sides I squared, that's what I'm multiplying here. And then times cosine of the opposite angle to the side we're looking for. So notice side C, angle C, side B, angle B, side A, angle A. Now, I'm just going to tell you this right now. In my experience of teaching, I've seen some of the most innovative screw-ups ever in the history of human beings. Yes, I've seen people go a squared plus b squared plus 2ab cosine C. That's bad. I've seen people go a squared plus b squared minus ab cosine C. That's bad. I've even seen people go a squared plus b squared minus 2ab sine C. Now that's one of the worst ones. It's law of cosines, not law of sine. So, now I would advise that you actually learn the correct law and don't try to come up with a new innovative way of screwing up. Okay, so when is the law of cosines useful? Well, notice, what do I need? Well, I can get a side if I have the two other sides and the angle in between. Notice angle C is in between side A and B. Angle B is in between sides A and C. And angle A is in between sides B and C. So if I have side angle side, which means two sides and the included angle, or if I have all three sides, side, 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 then I can do it. Because notice, if I have A, B, and C, then I can solve for angle A, or angle B, or angle C. Okay, so let's check out an example.
Bam! Do we have that in a Christian school?
That's annoying. All right, so notice I have side angle side here. And so what I'm looking for is side A. Well, how do I do that? Okay. I go A squared equals B squared plus C squared. Well, I just went backwards. Okay, so you just square each of the other two sides. Then you go minus 2BC, or 2CB as the case may be, cosine what angle? Well, I'm looking for A, so I use angle A, and I know angle A is 35 degrees. So let's just put that in there. Okay, so A squared equals C squared plus B squared minus 2CB cosine A. Time to crank it out. So I'm going to go 144, enter, 400 plus. So I just have these two numbers first. Now, I don't need a calculator to go 2 times 12 times 20, because I know that's going to be 40 times 12, which is 480. So I just go 480, enter, 35, cosine, don't forget to ensure that you're in the degree mode, then times minus. So A squared is 150.807. That means take the square root of that, and A is going to equal 12.28. Now, is that reasonable? Well, yeah. Notice, if this is 20, 12.28 is reasonable, or if that's 12, this is slightly more than that, so 12.28 is reasonable. Now all I have to do is get angle B and angle C. Well,
Bam! Do we have that in a Christian school?
That's annoying. Okay, so we just found side A, so now we have all three sides and one angle, so we're back to law of cosines. We're back to law of sines. So let's do that then. I've got A, or sine of A, over A, which is what I have in my calculator that I just figured out, equals sine of angle C over side C. Okay, so that means okay, now what I have in my calculator is the 12.28. Now it's on the bottom, so I'm just going to hit reciprocate, and that's going to give me basically the number on top that I multiplied by sine 35. So I'm just going to go sine, or 35 sine times that, and now I have what's on the left side. Multiply by 12, and I get 0.560482. So now that's sine of C. So that means angle C is going to be the inverse sine of what's in my calculator. And that's 34.089 degrees. So 34.09 degrees. Once again, that looks reasonable with this triangle. Now what I'm going to do is I'm going to add 35 to that. And now I have the two angles. All I do is subtract what's in my calculator from 180. And I end up with 110.9 degrees for angle B. Now, there's a little snag here that you may have encountered. Let's say instead of doing sine A over A equals sine C over C, what if we went sine A over A equals sine B over B? Well, and I know side B is 20. Well, I'm going to do the exact same thing that I did before when I had this, is I start with my 12.28. I reciprocate it so I can get it on top. I multiply by sine of 35. And then I multiply that by 20. So I get sine B equals 0.934. 0.93416, so go 0.9342. All right, so now that means I take the inverse sine of 0.9342, and I'm going to end up with 69.1 degrees. Well, notice there's no way that angle B can be 69.1 degrees. What went wrong? Well, this is correct. Sine B is 0.9342, but it's actually not 69 degrees, but it's the one over here that we have to get by subtracting that from 180. So when I go 180 minus that, change signs, I end up with 110.9, and that's what I thought, 110.9 degrees. That's the actual angle B. Now, how do we know? By just looking at the triangle and using our common sense. Okay, now, well, here's the other way we know. Is let's say if we had done angle B equals 69.1, then we'd end up with a different angle C. Then when you plug them all back into your law of sines, they won't work. Okay, that's it, game over. Now, here's a triangle where we're given side, 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 and we need to solve it. That means I need to get all of the angles. Well, law of sines is useless because we don't have an opposite angle. So what we need is law of cosines again, and so what we're going to do is say, well, we'll start with c squared. C squared equals a squared plus b squared minus 2ab cosine angle C. See, I have 17 on the left, so angle C has to be the cosine angle. Now I just solve for cosine C. So what I'm going to do is just start with 17 squared, which we know is 289. And then subtract 64, subtract 100. Now, so what I basically have is negative 2 times 8 times 10 times cosine C equals 125. So now I just divide by, well, 2 times 8 times 10 is 160. So let's just divide by negative 160. So 160, change signs, divide, and so cosine C equals negative 0.78125. So I take the inverse cosine of that and end up with angle C is 141.375, so 141.4 degrees. All right. Now what I do is go back to the law of sines to get angle A or B. So let's try angle A. So I'm going to go sine of A over 8 equals sine of 141.4, which I have in my calculator, over 17. So what I'm going to do, since I have it in my calculator already, I'm just going to hit the sine button, multiply by 8, divide by 17. Now sine A is what I have in my calculator, so inverse sine of what I have in my calculator is angle A. 17.08 degrees or 17.1 degrees. Now, that makes sense looking at the drawing. I add my 141.4 to that, and I subtract that from 180, and I end up with 21.5 degrees. So angle B is 21.5 degrees. Now, you can use the law of sines to check the whole thing. So all I do is go sine 17.1 sine A over A equals sine B over B equals sine C over C. Notice the bigger or the smallest angle has the small side, the medium angle has the medium side, and the biggest angle has the biggest side. When I do all these ratios, I'll find out they're all equal. That's happy.
Bam! Do we have that in a Christian school?
That's annoying. Hold on. Next thing we want to do, we've learned how to solve triangles. We can get sides and angles from any triangle. Now what we want to do is find the area of a triangle. Well, you know that the area of a triangle is 1/2 base times height. That is a right triangle. And if I have a rectangle, basically it's going to be half of the area of the rectangle. So base times height would be the rectangle multiplied by half. Well, if I make it not a right triangle, I can do the same thing. I just take the height of the triangle and multiply by base and 1/2. 1/2 base times height. Now, let's look at triangle ABC with sides A, B, and C, and say H, the height, is this segment right here. So sine of C equals H over A, opposite over hypotenuse. So that means if I multiply both sides by A here, then I get H equals A sine C. So now, area equals 1/2 base times height, but I just found out that the height is A sine C, so now I see that the area of this triangle is 1/2 base times A sine C. So 1/2 BA sine C, or 1/2 AB sine C. Notice if I have side, angle, side. All I do is go 1/2 times the product of those two sides times the sine of the angle in between. That gives me area of the triangle. So, if I have side, angle, side, then I can go 1/2 AB sine C, or 1/2 AC sine B, or 1/2 BC sine A. So it's 1/2 times the product of any two sides times sine of the angle in between. Piece of cake. Okay, now, what if I'm given two angles and a side? Well, here's a new formula for that. Area equals 1/2 times one of the sides squared. And it could be any one of the three. Now, what do I multiply by? If I'm using side A, then I go sine B sine C divided by sine A. So notice the opposite side is always on the bottom. So 1/2 B squared sine A sine C over sine B, or 1/2 C squared sine A sine B over sine C. Another simple formula. The third formula, what if I'm given side, side, side? Well, then we have to go to a Greek dude by the name of Heron. He found out that area equals this. Well, S equals A plus B plus C divided by 2. So what I do is add the length of all three sides, divide by 2. That becomes S. Then I go that term times S minus A times S minus B times S minus C. Take square root of the whole thing. I have the area. So once again, a really simple formula. So it seems to me that it would be prudent of you to actually memorize these three formulas.
That's the smartest thing I've ever heard anyone say about anything.
Okay,
Bam! Do we have that in a Christian school?
that's enough. Hold on. Cruising onward. Let's try this. Find the area of this triangle. Now notice we have side, angle, side. So we're going to use area equals 1/2 times 12 times 5 times sine of the angle in between. Now, I'm not going to go 1/2 times 12 times 5 in my calculator, because I know half of 12 is 6, 6 times 5 is 30. So all I'm going to do is go 30, enter, 20, sine, times. Bam! And there's the area is 10.26 square feet. Notice the sides are feet, so the area is going to be square feet. Notice also, you write it feet to the second power, you say it square feet. Okay, now, you want to also look at this and see if it makes sense. What would the height be if we dropped a perpendicular down here? Looks like the height would be about, let's see, if this is 5 here, it looks like that could be about 6. So, let's see. It actually could be less than that. It could be 5. 1/2 base times height, 1/2 times 5 times 5, 12.26 is in the ballpark. Okay, cruising onward. All right, now notice we're given angle, angle, side. So what do we do? Well, if we want the third angle, all we have to do is go 35 plus 20 is 55, subtract 55 from 180, and I get 125. So now, now I have area equals the one half times 8 squared times the fraction. Now I know I have sine of one angle times sine of another over sine of a third. Well, I know that the opposite angle goes on the bottom. Sine of 20 goes on the bottom. And what goes on the top? The other two angles, and it doesn't matter what order they are. Okay, so that's it. Crank these puppies out. So 8 squared is 64. 64 times a half is 32. So I go 32, enter. 35 sine, 125 sine times 20 sine, divide, and let's just multiply the whole thing, and we have 43.959. 43.96. Oh, this triangle is from France, so 43.96 square centimeters. And once again, with the side being 8, that's reasonable. Okay, cruising onward. Now we have 3 sides. What are we going to do about that? We need Heron's formula. So what we do is we go area equals the square root of some stuff. Well, we need S first of all. So let's just go over here. S equals 5 plus 4 plus 7 over 2. Well, that's 16 over 2, which is 8. So S is 8. So area equals 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. Bam! Simple as that. Okay, so that means it equals 8 times 4 times 3 times 1. And 8 times 4 is 32 times 3 is 96. So the area is the square root of 96, which is approximately 9.797. So we'll go 9.80. 9.80. The units are inches, so we have square inches. And 9.80 square inches is reasonable since the sides are 5, 4, and 7. Okay, that's it. Piece of cake. Have fun with these.